Today's session is all about Apex studies and post-processing. So basically everything after if you've set up your boundary conditions, you've meshed your model, and now you want to solve your model that you set up and eventually post-process. This is often the most important part, because if you can't represent your results in a convenient manner, then it doesn't matter that you have an accurate model, but you have no way of presenting it. I just see my presentation, however, did not, for some other reason, it's not responsive. Okay, so I'll just, for now, just quickly carry on this. So just quickly again, how these webinar sessions will work. So we plan to have one at the on the last Friday of every month. You only need to register once. Then you should receive an invite that is scheduled until the end of the year. And then we'll add topics based on your feedback. So the first session was on Apex custom tools, and today's session is now then on Apex studies and also on post-processing. And yes, we will have a website for this. It's just still in process. Then I would like to just draw your attention again. I see there's an issue there. It's not the CFD Tech Day, it's the MARC workshop. But in any case, the MARC workshop that will be presented by Gerrit will be on the 13th of April. So you can register via this QR code, but I'll also just post the link to this registration form in the chat afterwards if you have not registered yet. So then I will move over to what we're here for, and that's for Apex. So this is an Apex model that I have. As you can see, let me just quickly hide the solids. I've already...
Okay, yes. Sorry. For a moment there, it looked like we didn't see Apex, but it's coming through now.
Okay. Okay, so this is a model that I've already basically prepared up until the point where I need to go and solve this model. It's a fairly simple model that I've chosen just to make it easy to quickly solve and showcase everything that I need. So this is some type of bracket that's mounted to a wall here at the back. And then there is two load cases. The one load case, there's the pressure applied here. And then there's another load case where there's just a load applied to that hole. As you can see here in the model tree, there's the part, and then there's already sections assigned, there's loads assigned, and there's boundary conditions or constraints, and then a material. Okay, so at this stage, most of us will just say, okay, well, the next stage is to solve this. So we'll just go and say, place this in the analysis scene. And here I then see, okay, well, I have one issue and I specifically left this issue here because now you say, okay, well, I have an invalid connection definition. And now you say, well, I have loads of connections for this model. There's 50, and that's already quite a few. In larger models, you will maybe have hundreds. So what connection did I not define correctly? Did I define only one connection not correctly, or did I make a mistake with all of them? Now, what a lot of times you forget is if you click on this, Apex actually helps you and shows you what is missing. Now, in this case, there is only one connector that I forgot to assign a material, or a material and a diameter. And if you click on this, it actually already gives you the button to go and edit that specific connector. And now I can just say, okay, for this specific case, I know those hole sizes is 15 millimeters. So I can just quickly add the diameter, and I can add steel. And now you can see all of my problems have been resolved. The rest is basically just warnings that's given to me. If you want to go and locate that connector, I think I haven't showed it now, but you can just right click and say zoom to, and it will actually zoom in on the area where your issue is that you need to fix before you can solve. Okay, but now we can solve. And in most cases, most of us will just say, okay, well, let's just solve the model without even paying any attention of what happens further. And that's exactly what we want to look at first before we go over to post-processing. I see my computer is just taking its time, but let's quickly solve it. It should speed up. Okay, so now I have results, and I can go to post-processor, and it will load my results. And if you could remember correctly, I said I wanted to analyze 2 load cases, but if I now, let's just quickly put off the deformation. Let me just quickly put it off there. I can see for this specific event here, there is both my pressure load that I applied as well as my force that I applied to that hole. So I did not specify my load cases correctly because my initial idea is this is one load case here where I applied my pressure, and the other load case is where I attach something to that bolt hole. And those are 2 different scenarios. So if I go back to my model view again, and I now go to the studies tab, I can go and investigate a bit what was done. Initially, I just said, let's solve it, and I did not worry any further. And I can see, okay, I have one event here. And if I go and click on this, I can see, well, both loads as expected is included there. So by default, if you don't change anything, Apex will just throw in everything that you've placed in the analysis scene into the model itself. So I can quickly go and fix this by just say, okay, for this specific scenario, it will be easiest if I can just duplicate this event and then just quickly make the change for these 2 events. I can go and add events as well, but now my events is red, and I can just go again and to my study, and I can run the simulation again. Okay, you'll see then if I run the simulation again quickly, I'll just quickly show you that everything is now working correctly. I will have 2 load cases now. This is also the reason why I selected a small model, because if I have to solve something larger, it will take quite a bit of time. Now, if you go over to the post processor, you will see I have both events there. And in this case, in event 1, I can see my pressure load is no longer there, but I still have my force that I applied here at the hole. And if I go to event 2, you can see now I don't have my load there, but I have a pressure load applied there. So yes, everything is working as expected. Okay, so if we go back to the studies again, you will also see now that for some or other reason, there's 2 studies here. So by default, if I delete this study here, if you open any Apex model, there will be a study here that's been created beforehand. Now, there's 2 ways in which you actually can create a study. So you can use this study and set up your model from here, or you can again go and say place into analysis scene. But instead of just hitting the running man, you can actually go through these steps. So you're supposed to work through these steps from left to right. So you should actually just say, create the study. Then it will take you to the studies tab. It will create the study. If you need to add events, you can go and do that. there's multiple ways to add events. You can do it here. You can add events here as well. So one thing that I should also mention is there's a lot of ways to do the same thing within Apex. And then you can run. Okay, but let's, for instance, say you did not follow the route of placing the model in the analysis scene. You set up your model as you want to do it, and you move over to the study tab. So you can decide to use this study that has already been created. But for instance, let's say this was also not there and created from scratch. So the first thing that you need to do is you need to create a scenario. Now, when you create a scenario, you can obviously name your scenario, and then you need to select what type of analysis you want to do. So for this specific case, I'll say I just want to do a static, and it already asks you how many load cases or events you want to simulate. So let's, for instance, say 2, because we know we have 2 load cases. And now you need to work from the top to the bottom. So if I right click here, I can again say place in analysis scene, but you will interestingly see now it gives me an error that it can't find my mesh. And that is, if you understand how it works, that's exactly what you expect, because you haven't given it anything to analyze it. You've just created this scenario and you said place in analysis scene. So you actually need to give it something to analyze. And this is the next step. So to associate a model representation. Now, this can be a bit confusing, but actually what you're doing, you're just giving it a model, but you also have this thing of a model representation, and I'll quickly show that as well. But for this case, I'll say, okay, I just want to give my whole, or put my whole model into the analysis, or I want to analyze my whole model. You can do it on a specific part, but for this case, we'll just do the whole model. Okay, so now I have a part in there, and you'll see this error message here still does not go away. If I go to the analysis, now I have a new issues to worry about, and it's just say it miss constraints and loads now. And again, it's just because I have not given it any loads or constraints for my specific events. So I can quickly just add them here, this event, and for this one, I want these. And we should now see that now we're basically at the stage where everything missing a material property. So somewhere I am missing a material property now. Okay, but for some other reason, it moved over to normal modes. Let me just quickly see, just quickly delete here and just create a new scenario. Okay, but I can quickly show now the whole idea behind model representations as well. So for this specific case, I made it fairly easy, but the whole idea is that you can analyze different representations of your model. So for instance, in this specific case, I've just added another bracket. So this might be another representation. Instead of mounting this specific bracket in this fashion, you can maybe have another representation where you have this bracket instead of this bracket, and you want to analyze that. And then you can go and create a representation for that. So you can either do it on model level, you can just say add a representation, or you can do it on assembly level as well. And now you can create a model representation where I, for instance, exclude this red plate here. So that's one configuration. And I can add another one where I say add a representation, and in this case I include that one and I exclude the top plate. So now okay, let me just quickly say that is my second representation. Okay, so now I have those representations there as well. So I can now go and say, instead of only just associating a specific part, I can now, or an assembly, I can now associate a specific representation. So just to make sure that things work as expected, I will select the second representation. So ideally, that means that I'm including this red bracket. Now, because this is not meshed, I don't expect this to take part in my analysis. Just quickly want to mute. Someone is not on mute. This. Okay. I don't know. Okay. So let's just quickly add on loads again for this specific scenario. Just quickly make sure I need to swap them around for this. Okay. So that's done. And now I can just quickly run through the rest of the stuff that you will see for specifically for a static analysis. So if you have something with temperature, there's settings that you can set for this. If you have a non-structural mass, there's settings for this. For this specific analysis, it doesn't have anything with temperature or non-structural mass. If you go to the simulation settings, for a static analysis, the only setting that you can set is, do I want to check for mechanisms or not? What that does is, if there is a mechanism in your model, meaning that not all 6 degrees of, or not all 6 rigid body modes are fixed, then Apex will automatically go and perform a model for you to allow you to see where the issue is, what's not properly attached in your model. Then you can go and look at simulation status. Now, this is something that will only be populated after or during your model being solved. It will give you all the different stages that it goes through to set up the model. If there's any errors, that will be in that specific section. Then this is, I can't remember if this was there in previous versions, but it's definitely something that came in with Nastran. So this is the space where you can go and add any additional commands to your BDF directly from within Apex. It's exactly the same as Patron's direct text input application. If you want to add something here, you can just go and type the parameter, and then you just need to ensure that wherever that parameter needs to be inserted, so if you need to insert it into executive control, you need to type the parameter and also make sure that this box is ticked that that command will be written to the BDF. Exactly the same as Patron's direct text input. Okay, then the outputs by default, Apex will give you these outputs, so it's stress and displacement and applied loads, constraint forces, and section forces, but there is often additional outputs that you can request, for instance, like strain. So then it will just be added, and you'll see once you've solved, you have the option to plot strain as well. Now, just to quickly show you, before we place this in analysis scene, if I, for instance, create another scenario, say, for instance, something like a normal mode, the options that I have available here will be different. So I don't have the options to specify any loads, but only constraints. And if you know, modal analysis does not require any loads to solve. So there is no loads in this specific tree. If I, for instance, now go and look at the simulation settings, in this case, I can tell the solver I want the first mode, or I want to extract modes between these 2 frequencies. So for every type of scenario, you will have different settings available and different outputs as well. If you go to the outputs, you will see there's different outputs available for a modal scenario. So let's just quickly delete that and see if we can place this now into the analysis scene and everything is correct. So now this is in the analysis scene. I can see that my model is ready to solve. And again, I can use this button to solve, or I can go to the studies and I can solve by just right-clicking and saying run simulation. Now remember, for this specific scenario, I selected a configuration 2, and configuration 2 uses the red bracket instead of this bracket that I have constrained. So let's just see if the representation works as expected. And you can see there is no bracket there at the back. And as expected, that is what I think I will see. And the reason why I don't see this red bracket is because I haven't meshed it, and I also have not attached it to anything in my model. So that's why that is not included, but that was just quickly to show you that you can analyze different representations. So I'll just quickly now, instead of using this representation, I'll just quickly remove that and say that's not the representation that I want to associate. I want to rather associate representation 1, and I can quickly click OK, and I can rerun the simulation. Usually what I just do is I just place it in the analysis scene again to ensure that everything is still correct. And it now just says it's missing loads. So I'll just add loads quickly again to make sure that everything is as it should be. Okay, let's quickly just place it in the analysis scene again. Okay, everything is now correct. Okay, and we can run it again, but we've already seen the results now that we expect. The other thing that I just quickly want to show is I can do multiple scenarios as well. So I can do a static scenario, but I can also say, please do something like a modal scenario as well. So I can add my modal. And what you will see here is it will actually now show you that you're missing some things. So it needs a model representation. So I can give it a model representation. And again, here you will also see that it will require constraints. So I need to select all the constraints. As you can also see, in some cases, you will have the option to select all the constraints, in some cases not. So for the static load, I had the option to select all. In the modal, for some or other reason, I don't have this option to select all. Okay, so I'll just quickly add my constraints. And we, again, just can place it into the analysis scene. And now I expect one issue because I know I did not give a density to my material. So I can just go and quickly add my density. And I just need to add the mass property. And here I can just say, and I just need to correct that because I want it in SI units. And okay. So now that is also ready to solve. So I can go and say, let's quickly solve that study as well, because I want to have my modal results. You can see now there's no longer any errors. It's just warnings. So let's just quickly run the simulation. I just quickly want to, just want to run that simulation as well to make sure that we have all the results that we need to have available. And then we can move over to the post-processing part. So this is more or less what I wanted to show you in studies, is that you have quite a bit of functionality available. You can set up studies in many different ways. You can do multiple studies, multiple load cases. The naming convention is a bit different to something like pattern, but eventually you get exactly the same type of settings. They might just have different naming. And I'll just quickly wait for all the results to load. Okay, so let's quickly go through the post process. So when you work through these menus on the side, the specific case that you're active, or that's the active case, is always the one highlighted in purple. So if I follow that methodology, it tells me that I'm busy with viewing results from static scenario 1. I'm viewing results from event 1. And if I now go a bit further, you can see you can't really see what's happening here. So the easiest way to get rid of that is just to make this a bit bigger and you can see. And it says I am looking at results for representation 1. Okay, currently, if I go now a bit down, let's just drag this up a bit. Why doesn't it seem that any results have been loaded? Okay, so there is results. Okay, so I just quickly switch over to event 2. So for event 2, I can plot results again. This will now show you results. To plot, for instance, stress results, I can just quickly click on the stress results. For displacements, I have the option of plotting both it as a fringe or as a deformation. So I can switch on deformation or off. So these tabs will show you what type of results you can plot. For stresses, I can only plot a fringe. For displacements, I have the option of plotting it as deformation, as a fringe, or as vectors as well. Okay, depending on what option you select here, you will get a legend here. Now, this is a bit confusing if I not necessarily want to see both of them. So you can, here at the bottom, you can switch what you want to see and what not. So if I don't want to see the spectrum for my fringe plot, I can switch it off. For my vector, I can also switch it off. So that's just here. You can see the different settings available just to toggle what should be shown and what should not be shown. Probably the one thing that we use quite a bit is this one here. And this specifically is the hotspot detection tool. So this will show you, in this case, where your maximum displacements are. And you will often see that there is this arrow on the side. So that just means there is more options. So I can plot more hotspots. I can decide to plot min and maxes. So if you see an arrow next to it, it just means that you have more options available. Okay, then you can also plot something like a title. And if you want to add anything specific here, you can have the option to write anything additional to whatever you need to write there. So it will give you the basics. It will tell you the scenario and that you're plotting a fringe. And you can now go and add additional information if required. Then let's just quickly go and have a look at what we get in the spectrum. Okay. Oh, not in this. If you, for instance, plot a fringe, you will get specific options in terms of what you can do. So you can quickly switch units here. You can change whether it should be discrete or smooth, and then also you have the option of locking the spectrum. So if you, for instance, want to have a specific value here, say I'm only interested in, I want to see which spots has stresses higher than 2 MPa in this case. So everything that's above that will then be in red. You can drag these different sections as well if you want to do that. Then just in terms of here on the side, by default, it will only plot the top stresses, but for shell elements, you usually would plot the top and bottom. And then you can select here as well, what do I want to plot? So very much just setting up what you want to plot. Then in terms of visualization, there's some options here as well that you can select if you want to. If we just quickly go and say, okay, so you can just add different, in this case, the principal directions don't really make sense, but for instance, if you have something like composite, then your principal directions would make sense because that will depend on, or that will influence your material properties. Then there's a few other things that you can also set here. These two are fairly important, but these are maybe for me the most important is understanding what you're doing here. So by default, Apex will plot the average stresses. Let's just quickly put on the elements. So it will make a nice smooth stress contour over this. If I now say no averaging, it will basically just plot the stresses that it calculates for every single element. In this case, you don't really see it that nicely, but here maybe you'll see that now the stresses that's plotted for every element doesn't look as smooth as it should be. And there's a very good reason for that. If you did the FEA 101, we actually go into a bit of detail on how the stresses is calculated in every element, and that explains what we are busy seeing here, but I'm not going to go into that detail now. But the important thing is this, also to note, is what's the difference between averaging and smart averaging. So averaging, by default, what Apex will do is it will average results that is part of one part. So if you have anything that is part of this specific part, it will average the stresses over all of the elements, or average the stresses as the element over the elements. But for instance, if you have something that is connected to this specific plate, but it's not part of this specific part, it won't average the stresses between those parts. So it will only average stresses part by part. If you, for instance, stitch all of your parts together, then it will be one part, then it will average that. In some cases, that's convenient. In other cases, you're actually not representing or presenting the correct results there, because usually if you have different parts, they will show different, or you won't want to average that. But that's just something to keep in mind. Then the other one is smart averaging. In this specific case, it won't have any effect on the results. But what smart averaging does is if you have sections that have different thicknesses, it won't average where you have a transition from one section thickness to another. So that's what smart averaging does. I've already shown you no averaging, and then the difference is again a good tool to use. My spectrum is incorrect now, but it will basically, instead of plotting the stresses, it will plot the difference in the stresses between elements to show you again if your mesh is fine enough. So the finer your mesh is, the less the difference will be between for instance, an average result and an unaveraged result, because in most cases your results will get closer and closer to one another, and you won't see something like you're seeing there. That doesn't really make sense. Okay, then the last one here is the system. So by default, your results is plotted in a Cartesian coordinate system. But you also have the option to plot your results in a user-defined system. Now here you can, it will give you the option to create a coordinate system here in the interface. But if you, for instance, have other coordinate system that you've defined in the preprocessor, you can also use that coordinate system to plot, for instance, if you need a cylindrical coordinate system to plot your results in a cylindrical coordinate system. The only drawback with this specific option here is it needs to be a coordinate system that is referenced. What I mean by that is that coordinate system needs to be referenced by either a boundary condition or a load that is part of your analysis. Otherwise, it won't be seen in your model tree. You can see there is no coordinate systems here in my model, but as far as I remember, I did put a coordinate system in, but because I did not reference it, it does not show up. I just quickly want to see. So you can see the coordinate system that is created for you. If you just say define manually, then it will create a coordinate system somewhere here in the interface that you can go and move around now, and you can go and change it from a cylindrical to a Cartesian to a cylindrical coordinate system, and your results will update accordingly. Okay, so that is, so yeah, if you want to change it, for instance, to a cylindrical coordinate system, you can do that, and then you can see, well, it won't make sense in this specific case, but you can see my results updated. Okay, so that is more or less just what I wanted to show in terms of the spectrum and the functionality that you have here. The only thing that I just quickly want to show here as well is if I, for instance, now select vectors, my visualization options changes again. In this specific case, vectors doesn't make sense for the plot for the whole model, but where vectors might make sense is I can plot results for anything that's in this specific tree. So I can plot results for a specific part. So I can just double click, and now you can see my purple is now for this specific part. Now, what you should also just remember is there's no results there. When you select a new part, you just need to toggle on and off the fringe plot that you wanted to plot. So you can see now I have results only for that specific part. And you can do it for any part that is in this specific model that you've analyzed. But you also have the option of, for instance, going and selecting something like a constraint if you want to see reaction forces. And if I do that, you'll see the results that I have available now is different. So I can now go and look at the constraint forces. So in this case, I can only plot the vectors, but that will make sense for me in this case, or in a lot of cases, it will make sense to now plot the vector here because I'm only interested in the specific areas where that constraint is applied. I can go and get values there as well. I'll show that a bit later. But again, I can now go and change these visualization criteria again to make it easier for me to visualize whatever I'm seeing here. So that's also just something that I just want to reiterate again, is if it's in this tree, you can just double click on it, and whatever results is available for that specific thing will be shown here, and then you can go and plot it. This is, again, one of the things that's not necessarily that obvious, but you do have the capability to plot results for different parts in your assembly. Unfortunately, at this stage, we do not have the capability yet to go and, for instance, select the specific element and plot only the results on that specific element. I'm sure that will come in the next few releases. Then you will have full capability to go and analyze anything within your model, from part to elements. So yeah, like I just need to mention that you can't select elements yet. You can go and select elements here, but it doesn't really do anything. Let me just quickly go and select. So I can, for instance, say I want to select elements, but I can't at this stage do anything more with this. I can't analyze or plot results only for those selected elements. That's something that still needs to be implemented, but I'm sure we will see that in the near future. Okay, so just again to run through what's important here. Okay, here's one thing that I still need to show here. So if you now look in the model results, we're displaying the post model results, but there's availability. Again, if there's an arrow, you can click it. There is some type of drop down. I also have the pre-model available. Now you can see here everything is switched off, but if I switch it on and I just put my displacement deformation back on and I select my whole model and just quickly plot my deformation again, I can see now that just plot the fringe as well, then it should make it easier to distinguish what is the. So here is my deflected or deformed model, and you can see there is my original model as well. If I want to just go back again, that I do not see my undeformed model, I simply just switch it off and I go back to my post model. Okay, so then some of the other interesting tools that's also available in the post-processing is, let me just quickly get rid of all the different things on the screen. So in this specific case, I'm only plotting results for event 2. But say, for instance, I also want to plot results for event 1 because I want to compare them. I can just right-click on it and say, please add another graphics window for me. And then by default, you will now see Apex will split the screen into 2, and you will have event 1 and event 2. Now, the best way to figure out which is the active one is the active one will be the one with the rectangle around the screen that shows you the active one. If you want to make this one the active one, you can just double click on it and it will move that to the active one. And you will see that is event 2. And this, I think, should now be event 1. Yeah, so you can see it also updates here as well. So again, if you want to know which specific analysis you're busy with, just look at what is highlighted in purple. So I can do that. So there's different ways of viewing it. It by default will always show it as if it's next to one another, but I can also put it as single screens and I can create views here at the bottom. So now it's just separate windows. So you can create as many views as you want. You can add the modal scenario as well. So I can say, well, please add my modal scenario as well. So now it will quickly load the modal scenarios results, and there I have my modal analysis. If I play that, that's just to quickly show you. So now I have essentially a view of event 1, event 2, and then my modal results all in one. So that can make it really easy to process multiple events at once. I can also display them as this. So now I have all my different events available in my post-processor as well. The other thing that I also want to show here, let's just quickly move back to one screen now. So that's in terms of views. Then you also have this option of adding a collection. So a collection, again, is a new container. So I can also go and, for instance, say I want to plot event 2 in a new collection. And then it will open up a collection here. But now it's only event 2, and I can add, again, different views to collection 2. So you do have quite a bit of capability in terms of comparing results, plotting multiple results. For the specific case, I'll just stick to one collection with the 3 views that I have available. I'll just quickly want to, instead of looking at modal results, we'll just go and look at one of the static results again. So the one thing that I still need to show is the tools here at the top. So let's just plot stress on there, and we have something to work with. I have this probe tool that I can use. You can see it's activated now, but it's just behind this spectrum. So I'll just move that away. And for instance, I can now go in, interrogate elements, but for this case, I'm interested in extracting some stress results. So I just need to pick, I want to extract results from a fringe, and I can go and pick results as I want to. And if I want to now show all of this in a table, I can now get all of those selected results in a table, and I can export those results to an Excel spreadsheet as well. Then I also have the option of, instead of just probing specific elements, I can also use the option of, say, for instance, I want to look at results, how the stress changes as I move further away from my hole. I select the points that I'm interested in, and then I just middle mouse button to see how the stress decays as I move further away from my table, from my hole. Okay, then there's still one other thing that I quickly want to show you before we end off, and that is the sensor. So the sensor is something that is set up in the post-processor, in the pre-processor, but it's actually something that you only use in the in the post-processor. So in my opinion, it should actually be in the post-processor. So what the sensor does, it allows you to extract results either at the specific point, or in this case, at the specific plane. So I'll just select a plane, and instead of just selecting one plane, I'll say multiple planes, and it just says, I'll just tell it to select all objects, and now it will insert planes. I can, for instance, say I want to extract results at 10 planes, so it will automatically space these planes. I can go and move this line to wherever I want. I can just click on that ball and move it to wherever I want. But for demonstration purposes, I'll just create this one sensor. If I now go back to the post-processor, I will have the capability to extract results from there as well. So now I have my sensor available. I just quickly want to switch off some of these. So now I have this option available here. And again, like I said, you can just click on this and just please say I want, for instance, now why doesn't it want to give me results? Maybe I should be able to not rerun the simulation, but let's just quickly do that to make sure that we have the correct results available. Just to make
you don't need to rerun the analysis.
Yeah, but
it should be available.
Yeah, but I don't see it now, so I don't know if that is just something that I did. We can just quickly look again, but I don't see any results that I can use. So let's just quickly, just to illustrate everything, I'll just quickly rerun the static scenario just for ease of use. I'll just delete those and let's just quickly run this simulation again. Okay. Okay, let's see if we have results. Okay, we have results there. The only thing that I can think is that it lost some of the results for some other reason. But again, so now I have results for this. So what this specifically does is, in this case, I can do a vector plot, and I'm looking specifically at the forces for that specific section. But there's something else that I can do, which I actually want to show, is I can also plot these as a shear force and bending moment diagram. So if I hover close here to the corner, you can see I'm currently displaying the graphics, but I can also say I want to plot an XY chart. Just to make it a bit more convenient, I'll just add an XY chart here. Okay, in this case, it's beneficial to plot it like this. Okay, let's just quickly plot this again. And now you'll see, instead of the vector option being available, I now have the chart option available, and it gives me, in this case, the shear force diagram, or I can also plot the bending moment diagram there as well. And there's a lot of different options that you can do here as well. If you have multiple designs here, you can plot the shear force and bending moment diagrams for both of the different configurations that you have, that you can see how they differ from one another. But that is just one feature that I wanted to show. Another thing that I just quickly want to show as well is, if you hover here, I can also just, if I don't want this viewpoint anymore, I can just quickly get rid of that. So that's just something to keep in mind as well. If you often hover here in the corner, there might be options available to you as well.